Action.
Dr. Bilo.
Dr. Knack, Düsseldorf, Media Harbor.
Yep.
What are we doing here?
Right, this one is about punched windows in a wall. It's actually a rather simple technology. You have a solid wall, masonry, concrete, whatever. You punch a hole in there and you place a window.
So the most common window types for residential buildings, schools,
Yeah.
offices,
Yeah.
a load-bearing wall, a hole in it, a window.
Yeah, that's
And nowadays, cladding, because we don't build massive anymore, it's a game of layers. So we have a load-bearing part, insulation. Oh, that's tricky.
That's tricky. That's pretty much the point. So this this building physics aspect to improve the performance of the solid wall,
Yeah.
insulating and also defense for water. That can be done in that system. Then the window itself has to do the same. And then the tricky part, because you buy both from shelf, the interface. So
Yeah.
you have the cladding system with all the ventilation, all the insulation necessary, and then you have the window itself. And these two, they have borders, and these borders need to link. So the interface itself has to perform in the same quality, airtight, watertight, insulating as a setting. And that's making these kind of things complex.
Yeah, especially because the walls right now with these layers, kind of like sometimes
Yeah.
30, 40 centimeters thick. And at the very end, it comes down on that section onto a piece of glass.
To the IGU
And
of
then,
2 layers.
precisely, and then, okay, that's a good one.
So that's what this is going to be about. We need to talk about the IGU, a window, how does that work? The window frame itself, different materials of the window frame. Then the interface to the solid wall where the punch window is located. And then the load-bearing part, the insulating part, the cavity, and then the outer cladding defense for rain.
If you look at these buildings, it's a Geary building.
Yeah.
Quite interesting because three sort of the same building. You see same style, free-formed facade, punched windows, but one is in plaster, insulation in plaster. The other is metal cladding, shiny and gorgeous, I would say. And then we have a very sexy building with all the mirrors. Huh? I'd like to see that from close. And then we have a brick one. So that's already quite a high level of detailing, especially for the complexity. We just have a look, but that's not part of our course, isn't it?
Yeah, that's you're absolutely right. This is a Geary building, so it's freeform architecture, and to create out of these off-the-shelf systems a freeform structure is rather complex.
Yeah.
They solved it here with the 3 different materials. That's why we're here, because I really like to see the 3 different types of materials.
Creating an overview also for our learners.
Our program here is going to be flush, so we're going to have a flush wall, we're going to have a flush cladding, and we're going to have a flush window to explain how this works. But say as a consequence, we also have to look at how this can be done in these complex solutions. And I think they solved it very, very smartly. Still, they used flush windows in these freeform facades,
Yeah.
and only tilted the cladding itself so that the surface gets these freeform structure. We need to have a look how this is done in here, and that expresses the interface, which then is an opportunity to start in the whole program.
Yeah, okay.
And within the program, this one is going to be developing the solid wall, the insulation, the cavity, the cladding as one setting, the window, explaining the window as one setting, and then getting these both combined and discussing it for various types of
So
claddings.
we will have different claddings.
Yes.
Okay, fine.
Yeah.
So I would say, let's have a look.
Let's go. So, this is the simplest version of a punched window. We have a solid wall, we have some polystyrol foam cladding as insulation, and then the whole thing is plastered. So when you knock it,
Yeah.
you-
So it's styrofoam with a render of clay or plaster around. I can imagine it's quite easy also to shape with a sandpaper or something
that's
like
the
that.
point. So what they actually did is they had some kind of free-formish main structure, and then they shaped the polystyrol, fixed it, and then it's plastered.
Yeah.
That's a simple way.
Yeah.
And then we have that freeform surface, and then they needed the punched windows. As I said, the windows have to be straight. So it's a window off the shell, which needs to be brought into this freeform structure. And how did they solve it? They actually created these additional frames with frame in the freeform structure.
So it's a box that kind of like protrudes out of it, but everything stays straight.
Yeah.
And then the cladding is just
Smoothly
attached to it. Yeah.
And this is the window itself, a standard window. Then the frame, and you see at the top, it stops. It allows also rain to drip off, and then we see the window sill here, which is really securing that in the punched hole, the interfaces are smoothly and clean brought in position, and then the window is brought into this frame. I really like this in detail because it's a simple solution for getting this freeform with standard windows solved. And then the plaster directly merges with the intersection with the frame.
It's a clever idea.
That's a clever idea.
So whatever the curvature of the facade is, you don't bother with that. You just have these windows as they are brought in position.
And we're going to see that with the others as well. I really like also this view because it really shows the freeform shape and how these frames are brought in
I
position.
will shoot up over there also.
We do that. Okay,
Perfect.
let's go to the next. So, this is the metal cladding version.
Stainless steel, actually.
Stainless steel. We have punched windows. We have a solid structure at the back, concrete in this case, and then is insulation. Within the insulation, there's some substructure, which then keeps the stainless steel shingles.
Yeah.
Shingles work like there's one, there's the next one on top, there's the next one on top.
So it's like the roof shingles. Each of them overlap. You start at the bottom left and then you end up in the top right.
And that's how it is done here.
Precisely.
The nice thing with the shingles is you actually can do easier freeform surfaces.
Yeah.
And you
Because they overlap and then therefore they have wiggle room.
And as this is a thin metal, they also can bend it to create this freeform facade, which we're going to see when we look up.
Ah, looks awesome.
Yeah, awesome. And then the window itself, punched in, same
same story over there.
as the other one. An aluminium frame, which keeps the interface between the cladding and the window system. And then the window is brought in position. The same drainage as we saw at the other side. Also, say this back cover to secure no water gets in here. The dripping off here. And then the joint between the boxed windows and the metal cladding, the silicon joint.
It's just a silicon joint. Yeah, okay.
Simple silicon joint.
To take care of the tolerances of the overlapping of the shingles.
The nice thing with these ventilated facade, if there's any leakage, if water gets in, it always finds its way out.
Yeah, it drops down underneath,
Yeah.
so that the insulation is always with a little gap in front of it secured.
So somehow water in the system finds its way out. So I wouldn't mind to use a silicon joint as, say, the interface.
Precisely. I really like it.
Yeah.
Good.
Okay, last version, punch window,
Obviously, brick facade.
brick facade.
Interesting also, have you seen? It's not curved,
Yep.
it's facetted.
It's it's a flush
Faceted?
surface and then tilted surfaces. You could do this in a freeform
Yeah,
setting
but it's
as
even
well.
more expensive, more
It's more complex.
more expensive. Yeah.
Again, it's a ventilated version. How do we know?
Yeah, it's the gaps over here.
Gets over here, so air gets in, any water in the system is drained out, and then somewhere at the top it's gonna find its.
Usually I would expect that there's also ventilation openings on top of the windows, but there isn't, so therefore they might have found other ways of getting the air out and in.
But you're right, this would be, say, what we would expect normally. Then punched window, the same setting as before, with the aluminium frame system, with the windowsill, same setting, same punch window as in all the other settings, and again a silicon joint
Yeah,
to the ventilated facade, the brick layer.
yeah. You can see here it follows a little bit a different pattern due to the fact that the facade is already straight and not curved.
Yeah.
So the windows on one element of the facades are always the same
Yeah.
angle.
The geometries of the window frame which is brought in there, they're all the same. They're all the same.
Precisely.
In the other freeform settings, we had this curvature, then
Yeah,
they were
yeah,
different.
precisely, yeah.
And here, this is a flush surface, faceted, as you said, with different angles,
Yeah.
and then they're all the same as setting. What we will see is when we look up, it's somehow finding a different position.
It's more free lines. I really like it. Also, especially the three of them together.
Yeah.
That's really nice.
Yeah, well, it's a very educational setting.
No, perfect choice.
Thanks, Düsseldorf.
So
Thanks,
it's
Gary.
really good.
Okay.